In this video, I'll try to explain the API Gateway and Autodiscovery. So before understanding these two things, it's important to have a basic idea of the API Gateway. So let's understand the API Gateway basics. Any API implementation will have two areas. One is the non-functional and the functional requirements. So the functional requirement have the business logic, whereas the non-functional requirement have things like SSL certificates, throttling, and basic authentication. So any changes required in the non-functional requirement, suppose tomorrow you want to add a caching mechanism to the API, or it could be some other requirements that involves modifying the code, and there it turn affects the functional requirement as well. Suppose the certificates need to be updated every 30 days, so again you have to update your code every 30 days and redeploy it. So that's not a good idea to do this. So we create an additional component called the API Gateway and move all of these non-functional requirements to the API Gateway. So what we got is we have separated the concerns from the functional requirement. Now everything is taken care by the API Gateway. Well, API Gateway does a lot more than this. There are multiple things like routing can be implemented, caching can be implemented, and a lot of things can be done. What's more, the API Gateway also gives you an idea about how the API is being used. It gives you a wide array of metrics and also tells you the violations of all the policies. So now that we have an API Gateway, we have separated the non-functional requirements from the functional requirements. We need a mechanism to manage this API Gateway. So how do we do that? In terms of Mule, we have the API Manager, and the API Manager with the help of Autodiscovery helps us to manage this API Gateway. Now how things actually work in Mule, let's get an understanding of that now that we have got the basic idea of the API Gateway. So let's move to the next slide. Now we can roughly divide the understanding in two different sections, like the control plane and the runtime plane. The runtime plane is also called as the Mule runtime, where the Mule runtime is hosted. Maybe it could be on Cloud Hub or it could be on the on-prem machines. So the control plane is your anypoint platform. Whenever user logins to anypoint.mulesoft.com, he is on the control plane. So in this case, I'll take an example of API Manager. So API Manager is a part of control plane, as well as the anypoint exchange is part of the control plane. So if I want to create a new API, I log into the anypoint platform and go to the API Manager. And in the API Manager, it gives me an option to manage a new API or an existing API from the anypoint exchange. So in any case, if it is a new API or an already existing API, it has a very tight dependency on the anypoint exchange, where all your assets like RAML are stored. So if you want to create a new API, even in that case, you create it via RAML or without RAML, it gets published as an asset to the API exchange. Once this thing is done, the API Manager will be able to allocate an API ID to the API, and the status would be unregistered because we do not have any API implementation linked to this API. So now that we have understood what things are happening at the control plane, let's shift our focus to the runtime plane. So the runtime plane could be on Cloud Hub or on prem systems. So the runtime plane can be divided into two sections. One is the implementation layer and the other is the orchestration layer. So the implementation layer can also be called as a backend API layer, where the actual API implementation gets deployed and it's running over there. And then the orchestration layer can also be called as MuleSoft API Gateway. So whenever you deploy your application, suppose it is on Cloud Hub, so it will get a worker allocated. Worker is nothing but a VM node, and that then it will install a copy of Mule runtime and then start to deploy your application. So whenever it is starting to deploy the application, your Mule application, before that we have a runtime agent in the orchestration layer. The runtime agent's job is to facilitate a communication between the control plane and the runtime plane. So let's suppose we are deploying an application to the runtime plane. So the application has an element of auto discovery configured in it, and the auto discovery component has the API ID of the API which we want to register it with. So what happens is the while deploying, the auto discovery components communicate with the runtime agent, and it lets the runtime agent know the API ID. So when the runtime agent gets the API ID, it understands that it needs some more detail to communicate with the API manager. Like it needs the anypoint platform ID and secret, because any API ID belongs to some organization or business group. So to authenticate and authorize itself to that particular account, it needs the anypoint platform client ID and secret. So when the runtime agent gets all of these credentials, it takes this and goes to the API manager. So once the API manager gets this credential, it updates the status with the green color. As you can see, the API is now active, and as you can see, a communication channel has been established, one on the API gateway, and with and the backend API has also registered it. So what API discovery did, it has helped in getting itself registered with the control plane and got a communication channel established between the API gateway and the control plane, that is the API manager. Now suppose I want to implement some policies. That is the main purpose of doing this thing. So we want to apply some policies. So those could be the already existing policy which come out of the box, like caching, basic authentication, throttling, detokenization, and it could be your custom policies as well. So custom policies would be available at the exchange. So everything, policies, raml specification, everything has to be present as an asset in the exchange. So there is a tight dependency of API manager with the exchange. So now the policy, suppose a custom policy which is present on the exchange has to be applied to your application. So how does that work? API manager consults the anypoint exchange to get the policy. It gets the policy, and using the communication channel that has been established using runtime agent, the policy gets applied to your API gateway. So if you see, we have separated the concerns of non-functional requirements from the implementation layer to the orchestration layer. So now you are not disturbing the actual implementation layer, and you can apply policies at the runtime without any downtime. All right, so using the runtime agent, we can apply all the policies to the orchestration layer. So this phenomenon is called as enforcing a governance. We are governing the runtime plane from the control plane using the API manager, and to API manager to govern this, we needed a communication channel, and this has been helped because of the auto discovery mechanism present. So this is called as governance enforcement on the runtime plane. So now when any consumer wants to access your API, you have a basic endpoint exposed, and then the consumer will have to go through the API gateway. So the API gateway is acting as a guard. So if the request is valid and it is as per the policy, it will make its way through the API implementation and get back the response. So this is how the API gateway and the auto discovery work. Now let's see this in action using a Mule application. So now let's start with the control plane first. So I've logged into my Anypoint platform account. I'll go to the API manager to create an API. So let's click on manage API, and I do not have any RAML specification or any asset created in the exchange right now, so I'll create a new one. I'll give the API name as demo gateway. Asset type, I don't have any RAML specification as of now, so I'll publish it as an HTTP API, and that's it. Let's hit continue. Alright, so now I want it to be a basic endpoint. I do not want it to be a proxy. And then the Mule version, the API would be in Mule 4. So I'll select this and let's hit on save. I don't want to give any implementation URL as of now. So let's just hit save. So with all those detail, it has created an API for me, and the status is unregistered, and we have also got an API instance. So this is the API instance that we will be using for the auto discovery. So let's just copy this. Alright, so the control plane part is done. Now we need to do the runtime plane part. So let's create an application first to get it deployed on the runtime plane. So I already have an application which returns hello world JSON response and has an HTTP listener. So I'll configure a global element called auto discovery. So just search for auto discovery and it appears right away. Now I need to enter the API ID that I have got from the control plane. So I've pasted the API ID, and here we have an option to select the default flow on which we need to add. So I've added the flow. So I'll save this. The application is pretty much ready now, but a few more things I need to do. I also need to get the Anypoint platform client ID and secret like we discussed in the previous slides. So how do we get that? Go to access management. And in the access management, you can click on the organization. So this is the client ID and secret. Just copy and keep it in handy. So while deploying, we need this. So now let me just export this application. I'll export this as a Mule application, Anypoint Studio project to Mule deployable archive. So let's just export this now. So it will finally create a jar of this application, and we'll deploy that jar to Anypoint platform. So let's go to the runtime manager. So runtime manager gives you access to the runtime plane, although runtime manager will also come under the control plane. Anything controlling the backend systems comes under the control plane. So let's deploy an application, and so I'll name this application as API Gateway Demo. Application file, I'll choose the application file. This is the jar that just got created. Then I do not want object vstore. What's more, I need to add properties, the anypoint platform key and client ID and secret. Those are required, so that's the reason we copied it. So I've pasted the anypoint platform, client ID and client secret. Now we are good to deploy the application. So as we can see, the application has been deployed. Initially it got the API key ID as blocked. So later on, when the communication channel got established, the API status becomes unblocked and now it's available. So now let's just try to hit the API and see if we get the proper response or not. So we are getting the correct response. We are getting hello world. Now let's apply a few policies to this API, because that's the whole reason why we have added API manager. So let's go to API manager. And you can see the status has become active. Previously it was unregistered. So the API is linked with this. The implementation is linked with the API. Now let's quickly add some policies to the API. Apply a new policy. But before applying this policy, I need a client ID and secret credentials. So for the same reason, I would need to go to Exchange. And I need to request the access. I'll select the instance. This is the instance. Application, I'll create a new one. Demo application. That's it. Let's create this and request the access. So I've got the client ID and secret. Let's just keep this handy. Now let's go back to the API manager. Okay, and now we'll apply the policy. So let's just apply a client ID enforcement policy. Let's select the latest version. And I don't want it to be a custom expression. I'll use a basic authentication header. And let's apply this. So the enforcement policy has been applied. So now if we try to hit the API, we should get an error message. Maybe it takes some delay to get it applied, but in a couple of moments we can see invalid client message. So it's now giving the error authentication denied when we try to hit the API. So it takes slightly some amount of time to get it applied. It doesn't instantly apply. So now let's add a basic authentication and use the client ID secret that we just got generated. So this is nothing but a simple base 64 encoding of the client ID and secret. It gets finally converted into basic auth header. So now let's try to hit. So we have got the response, the hello world response. So this is how we can create an API and add an auto discovery to it, and we can apply multiple policies as and when required using the API manager. So that's it for this video. I hope you would have found this video useful. Thanks for watching.